Hello and welcome to today's lesson looking at how cables and plugs operate in the mains electrical circuits for the United Kingdom. Now this particular lesson is found in the electricity topic of GCSE separate science and GCSE combined science as well. So in today's lesson what we're going to cover is we're going to look at the features of a 3-pinned plug and the use of each wire in the plug, look at how a plug should be wired, and then examine the faults on plugs and then how we fix them. So this links into the following part of the AQA GCSE specification for both separate science and combined science. So as you'll see, it links into the electricity topic of both courses. So previously electricity, we've looked at things such as electrical circuits and electrostatics, but for the next couple of lessons we're going to look at how electricity is used in the real world and how it's used in the mains network of the United Kingdom. So we're going to start off at this by looking at the plug. So we're going to look at the features of a correctly wired 3-pin mains electrical plug and then recognise the errors that you can possibly get in the wiring of those plugs. So most electrical appliances like your TV, your DVD player, your laptop, your hair straighteners, your computer, they're all connected to the mains electrical supply, which is supplied to us by the national grid using a cable and a 3-pinned plug. Now, as we know so far, mains electricity is produced in power stations, but is transferred around the country into different homes, into different buildings, into factories, schools, offices via the national grid. Now, the mains potential difference in the United Kingdom is about 230 volts. The mains frequency in the UK is about 50 hertz, and the mains uses an alternating current to deliver this electrical energy around the country. So, most electrical appliances are connected to the mains using a 3-core cable. Now when we think of a plug, we think of this image, but underneath this plastic casing there's a greater complexity to your plug. Now most electrical appliances will have 3 wires or 3 cores in their cable. Now why do we cover the wires in this plastic layer as you can see in the picture? Well, there's actually 2 reasons. Number 1, it provides insulation to stop you electrocuting yourself if you touch the cable, as it prevents charge flowing from the wire into you. In addition, the plastic is flexible to allow the cable to move into different positions in your plug. And then finally, the different colours of the insulation allows you to identify the different wires easily. So if we need to identify these different wires, what's the function of each wire and what are they called? Well, you've got 3 different wires in your plug which each carries out a different job or a different function. So you've got the live wire, which is a brown wire, the neutral wire, which is a blue wire, and the earth wire, which is a green and yellow striped wire. Now, why did we select these different colours? Well, we select these colours because it doesn't confuse red-green colourblind people like the old system used to, and this system is standard across the EU and former EU countries such as the United Kingdom. Now, in the UK, originally, red was the live wire and green was the ground or the earth wire, and this was potentially a disaster if you couldn't tell the difference due to colour blindness. Now in Germany, red was ground, and this did actually cause a number of fatalities when British musicians were actually playing gigs in Hamburg, which indicated the need for a standard colour system across the different countries, because we used to have red as the live wire, so people got confused. And black and white wasn't an option because black was neutral in half of the European countries, but it's live in the USA and Japan, so this would have caused confusion if they were used. Now, the earth wire is a green-yellow stripe because you can't confuse a stripe even if you can't make out the colours. So even if you are colourblind, you'd still be able to recognise the earth wire because it's a striped wire. Now, each wire carries out a different job and each wire is made out of copper. But why do we make the wires out of copper? Well, we do this because copper is a good electrical conductor, so it'll carry the charge with little resistance. It's malleable, so it can be easily shaped into the correct shape you would like it, and it's ductile because it can be made into a wire very, very easily. Now, so let's just clarify what we've learned so far. A mains electrical cable contains 3 inner wires. Each wire has a core of copper. Copper is a good electrical conductor. It's malleable and it's ductile. The outer layers are a flexible plastic because plastic's a good electrical insulator, and we color code the insulation with the blue insulation representing the neutral wire, the brown insulation representing the live wire, and the green and yellow striped insulation representing the earth or the ground wire. Now, what is the function of each wire? Well, number 1, the live wire carries the potential difference from the power supply, okay, in the actual circuit, in the cable. The neutral wire completes the circuit so current can flow, because current can only flow in a complete electrical circuit, and the earth wire prevents the electrical device from becoming live. Now, in this instance, live means to potentially carry the current. Now, they're placed into the following formation in the plug. So you've got the earth wire at the top, the neutral wire is on the left-hand side, and the brown live wire is on the right-hand side. You'll also notice next to the live wire, you've got a fuse. Now, this is a device which is used as a safety measure to prevent overheating in your plug, which could be an issue because overheating can lead to the plug and the device catching fire. That happens because if the current flowing through the live wire becomes very large, that can cause overheating, which can cause your plug to catch fire. Now, we've also got to consider where the wires in the plugs lead. Now, basically, each wire links into a pin, which we call the pin which links to the terminal. Now, the pins on the other side of the plug form the prongs of the plug. Now, remember, the plug's been reversed and the pins are in the same position. So whilst it might look that the live and the neutral swap position, that's not the case. It's just because we've turned the plug over. Now, the terminals and pins are made from brass. Now, brass is used because it's a good electrical conductor, but also, very, very importantly, it doesn't corrode easily. So the pins and the terminals don't weaken over time, so your plug doesn't disintegrate after a couple of years of use. So, inside the plug, we've got the following particular wires, which each have the following job. So we've got at the top the earth wire, which stays at 0 volts and prevents electrocution. It stops the appliance from becoming live. On the left-hand side, you've got the neutral wire, which stays at 0 volts and completes the circuit. You've got the live wire on the right-hand side that alternates between 230 and minus 230, so it carries the alternating potential difference in the circuit. You've got the fuse next to the live wire, which melts if the current is too high and breaks the circuit, so prevents electrical fires, prevents overheating. And finally, at the bottom, you've got the cable grip, which holds the cable in place, so those 3 wires don't move around inside your plug. Now, the live wire is the wire which carries the potential difference, which is why this wire can be dangerous, which we'll look at in a second. The neutral wire is always at or close to earth potential, which is 0 volts. So the earth wire is at 0 volts. It only carries a current if there's actually a fault in the device. So if your plug is working correctly, the earth wire shouldn't be needed to be used. So there's an easy way to remember where each wire goes, and it's the second letter of the colour. So blue, BL, goes to the left-hand side, brown, BR, goes to the right-hand side, and striped, ST, goes to the top. So you can work out your configuration from remembering the colours. Now, in the electrical plug, we mentioned that the potential difference in the live wire varies from plus 230 to minus 230. That's because the electrons are moving back and forth in the live wire. The charge is oscillating. So you'll get a particular graph as the following. It goes from plus 230 to minus 230. Now, why is it going from plus 230 to minus 230? Well, that's because in physics, negative means in the opposite direction. So when it's going one way, it's a plus value. When it's going a negative way, it's going the other way. So as a result, the plus and minus indicates the electrons or the charge in the wire is going backwards and forwards. So the electrons in the wire are going backwards and forwards, backwards and forwards. So the electrons don't actually change net position overall. They're in fact going one step forward, one step back. So on average, they're staying in the same position. Now we call this particular idea alternating current, when the charge goes back and forth. Now an alternating current is produced by an alternating potential difference. Now, in an electrical plug, the neutral wire has a potential difference that stays at 0 volts. There's no electron movement in the neutral wire. The neutral wire is only present to form a complete circuit in your plug, in your device. It's not there to carry any of the energy. So there's no potential difference in the neutral wire. So what do we know about the plug? Feature 1. The case is made from a tough plastic or rubber because these are good electrical insulators. Feature 2. You've got 3 pins made from brass which are good conductors of electricity and they don't corrode, they don't oxidize. Feature 3. There's a fuse between the live terminal and the live pin. Feature 4. The fuse breaks if the current in the circuit is too high. And then feature 5, the cable is secured in the plug by a cable grip, so it grips the cable itself, not the individual wires. It holds, though, the cable in place. We know that there are 3 wires inside your cable. The live wire has the potential difference of plus 230 to minus 230, so it carries the alternating potential difference from the supply. The neutral wire, which has a potential difference of 0 volts, it completes the circuit. And the earth wire, which also has a potential difference of 0 volts, it only carries a current if there's a fault. Now, the earth wire, how does it work? Well, we know that it prevents the plug from becoming live, which means to potentially carry a current to potentially cause an electrical shock. Now, if there was no earth wire and the live wire touched the casing, the electrons would travel on the casing. It would become live. So what that means is if you touch the casing, the electrons would transfer from the casing to you, so you would get an electrical shock. Not ideal. Now, why does the charge, the electrons, travel from the plug to you if you touch it? This is a very, very important idea to understand, and it's because that basically electrons wish to get to the earth as quickly as possible, and humans have a potential of 0 volts. Now, the live wire, and therefore the plug, if it's touching the live wire, has a potential of 230 volts. So there's therefore a potential difference between you and the live wire. And there's a rule that if there's a potential difference between 2 objects in contact, a current will flow. Now, it's a fact that you've just got to remember that all humans have a potential of 0 volts. Now, basically, this can actually lead to some further issues as well, because a live wire always has a potential difference in it, even if the switch is open. So even if you touch the live wire and the switch of a circuit is open, you can still get electrocuted if it has a potential, because you as the humans have a potential of 0 volts, so any non-zero potential in that live wire causes a potential difference, so would cause charge to flow and you getting a shock. Now, if the casing, though, is attached to the earth wire is then attached to the earth or the ground, as the name suggests. This allows the electrons to travel through this earth wire and into the ground, making the casing safe again, because the plug can't be live. There's no chance of an electrical shock. Now, if this actually happens, if the electrons travel down the earth wire to the earth, to the ground, this will also cause your fuse in your plug to melt, because the current going through the device is very, very high, which then causes the fuse to melt, breaking the circuit and stopping the device working, which we call blowing a fuse. So what happens is, if the plug casing has electrons or charge on it, the electrons will travel to the ground. Why will they travel to the ground? Because the Earth's potential, like a human's potential, is 0 volts. So if the plug casing has a potential of 230 volts, there's a potential difference between the plug casing and the earth, so the charge will travel down the wire and will go to the ground. Now this would mean that there's no electrons or charge on the plug casing to travel through the human, so if you then touch it, you don't get electrical shock. Now the other way you can think of it is as follows. You can think of it as a current will flow only if there's a fault on the device, so it stops a current flowing through a human, because if you think about it, the human's potential, as always, is still at 0 volts. The plug's potential is also at 0 volts because all that charge, all that potential has gone down the earth wire to the earth, so there's no potential difference, so no current will flow. The casing is no longer live. Now, the thing you've got to be careful about, though, is a current will flow in the earth wire as there's a potential difference of 0 volts in the earth wire, and the live wire has a potential difference of 230 volts. So that live wire touches your earth wire, there's a difference in potential difference, there's a PD, so a current will flow. Now, now the issue is, because there's a large potential difference, because one's at 230 and one's at 0, a large current would flow. This could possibly cause the electronic device to overheat and catch fire. Now, the overheating occurs as current flow produces resistance, which dissipates the electrical energy as thermal energy to the surroundings. And if you've got a large current, because you've got a large potential difference, you can get a large resistance, which leads to a large energy dissipation, which can lead to the device catching fire. Now, there's also a special symbol found on certain devices, and it's basically two squares, one inside of the other. Now, what does this symbol mean? This symbol means that the device is doubly insulated. It has double insulation. Okay, now a device can be double insulated if they have more than one layer of plastic casing, or they've been designed so the live wire cannot touch the outer casing. This means the outer casing cannot become live even if the wires inside the plug become loose, because there's no direct connection between the live wire and the outer casing. So this means the charge can't travel to the outer casing even if there's a potential difference between the outer casing and the live wire, because there's no direct route. Now, this is important because it means that there's no possible way, if you touch that outer casing, that you would get an electrical shock, because the outer casing cannot become live, so you don't actually need an earth wire. So devices which have that double insulation symbol don't actually require an earth wire, because it's impossible for the outer casing to become live. So here's a diagram showing that. So as the second layer of insulation is in between the live wire and the outer casing, it's impossible for the outer casing to become live. So there's no need for an earth wire, as you can't possibly get electrocuted because the outer casing can't become live. The electrons, the charge, will get trapped on the first plastic coating, so they couldn't get to that second outer coating. Now, that's a very, very important idea to link across, and you've got to understand why double insulated devices don't actually require earth wires. Now, finally, the last thing is that if you have an electrical shock can cause a lot of damage to you as a human. It can affect your muscles, it can affect your nervous system, it can cause you to be paralyzed, and in worst case scenarios, it can stop your heart beating, which could lead to death. Now, you can get an electrical shock from anything which is plugged into or connected to the mains. Now, you can get an electrical shock generally when there's a fault with the plug of the device. So we need to know what the three major faults of plugs are. Now, number one is a fault in a plug can be that there's a bare electrical wire showing. So what that means is that the actual copper is evident underneath the insulation, so you can directly touch the copper. Now, that's an issue because that can lead to an electrical shock, as there can be a difference in potential. There's a PD, can lead to current flow, can lead to a current, which can cause an electrical shock. Another issue would be that the live and the neutral wires are wired to opposite terminals. Now, the issue with this one would be that the device would still work, but when it's switched off, it could still electrocute you. And finally, it can be that you've got the wrong fuse for the appropriate device. So say, for example, a kettle requires a fuse which melts at 9 amps and you have a fuse which melts at 13 amps. So what that can lead to is that the fuse doesn't melt at the appropriate current value, so therefore too much current can flow through that particular device, leading to overheat and catching fire. So those are some of the main faults which can link with the plug, okay, which can cause issues around the home, whether it be catching fire or being electrocuted. So just to clarify, what have we learned in today's lesson? We know that most electrical appliances are connected to the mains using a 3-core cable. The insulation covering each wire is color-coded for easy identification, with the live wire being brown, the neutral wire being blue, and the earth wire being green and yellow stripes. The live wire carries an alternating PD from the supply. The neutral wire completes the circuit. The earth wire is a safety wire to stop the appliance from becoming live. The potential difference between the live wire and the earth wire is 230 volts, with the earth being at 0 and the neutral wire as well, also at 0. The earth wire only carries a current if there's a fault, and you can explain why the live wire can be dangerous even when the circuit is open, when there's a switch open in the circuit, and you know any dangers of providing a connection with the live wire and the earth wire. So in today's lesson, if you've been successful, you can describe the features of a 3-pin plug and the use of each wire, look at how a plug should be wired, examine the faults and the dangers on plugs and how to fix them. Thank you for listening to today's lesson. I hope you've enjoyed this lesson looking at cables, plugs and the mains electrical circuits, and in the following lessons we will look at things such as mains electrical power and the national grid. Have a lovely day and take care.